Hi, and welcome to this part. In this part, we will study about arrays, how to declare them, use them, initialize them. Arrays are derived types. When I say derived types, that means arrays are not a type in themselves. That is, you can have an array of some primitive type, array of character, array of integer, array of float, array of doubles, and so on. Array of integer pointers. So this is a derived type, not a primitive type. These are constant in size. That is, once declared, its size cannot be changed. These are linear in memory. That is, they occupy one full chunk of memory without gaps in there. It's a homogeneous. Homogeneous in the sense the entire array is made up of same data type. Zero indexed. That is, it's an index type with index starting from 0 and it's a sequence type. C99 introduced variable length arrays. However, the length of the array should be known before declaration. The base name of the array refers to address of array. See, the way you access array is through index, and the base name refers to 0th index. And pointers and arrays are kind of related. We'll see how to access arrays using pointer notation when we deal with pointers. For now, we will learn how to use arrays using index notation. So remember, these are derived types, constant size, linear, homogeneous, zero indexed sequence type. And for variable length arrays, always remember that you need C99 flag when compiling. Otherwise, you will get compilation error. So let's see arrays in action. I have written this small program. So this is how you declare the array. This is an array of integers, of 5 integers rather, array of 5 integers, and name is A with no initialization. It will contain garbage value. This is another array of 5 integers initialized to 1, 2, 3, 4, 5. The initialization has to be within braces, elements separated by comma and terminated by semicolon. The declaration is terminated by semicolon. Note that this is 0 index, so it will start from 0 and go up till 4. So 5 elements, 0, 1, 2, 3 and 4. So this is how you iterate over an array using loop. For int I is equal to 0, I less than 5, I plus plus, printf so and so. You print the I here and array I here. Similarly, you can print it here, right? You can print it here. It will show you garbage value over here. Now, after scanning them, you take input for them, print them, and this is a multi-dimensional array, an array of 3 by 3. That is a total of 9 elements. You can have array of array of array. So this is the first row, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can iterate over this in a suitable fashion by using nested for loops and print it. When you try to pass an array to a function, you pass it by its base name, A and B. A and B are the base names. These are received like this, int array of A, array of B. Note that except the first except the first index. All other indexes must be definite. You cannot leave empty. If you cannot leave 3 empty, say you try to leave 3 empty and save it, then try to build it, give a compilation error, right? You must explicitly say that I have 3. And similarly, I have traversed and shown it. One more important point. Suppose you have an array size A, with name A, and it is of type int. How would you find how many elements are there if you don't know? Then you can use size of operator. If you apply size of operator to this, it gives you the size of full array, and then size of array integer, the type. So you divide by that and you get the value, right? Now this is a variable length array. Okay, you have n and I have declared xn, so you can scan it and iterate over it. This is how you access an array. Now arrays are used to implement a sequence, and these are very fast constant time operation, but it is fixed. Once you have declared it to be 5 size, it cannot be changed. Only in variable length arrays you can change this. Okay, so let's build it and let's run it and see how it works. So it asking for input. This is weird. Eclipse is weird as far as IO is concerned. Very bad console. So I input 1, 2, 3, 4, 5. These 5 will go to A, right? And then it is asking for that n of variable length array. So I enter 6. Then 1, 2, 3, 4, 5, 6. You see, x is the last one. 1, 2, 3, 4, 5, 6. This is our matrix, right? And just before xn, I have this is the size of A. So this is your 5. This is your matrix. Just before that, this part. And this is the initialized A. And this was printed in the function, these two. And these two are printed normally. And this is your garbage A0. And this is your array A. So that's how it works. There is one more way to initialize the array to 0, like this. Say 0, then the entire array will be initialized with that, with the 0. So you will see the difference in output. 1, 2, 3, 4, 5. 5 for A, when I say 1, and say 2. So x0 is 2. Now you will see A has become 0 just by initializing one element. So this is how it works. Arrays, simple, easy to use, multi-dimensional, single dimensional. There is one more way to use the indices. I have used the index here, I. You see how we are using the subscript operator. Remember our discussion of operator and operands. This is a subscript operator which is used to access the individual element of the array. So it will start from 0, go till all the way till the end, and then it will terminate, the loop will terminate. For 2-dimensional you have 2 subscripts, but note that in memory these will be stored linearly, because memory itself is a linear structure. Now another point which I'll show you here in comments is A0 is like star A plus 0, like this, okay? And A1 is like star A plus 1, okay? Okay. One more point I would like to make over here is, I'll show you rather than telling. printf, I'll print the pointer values of the addresses. Okay, so you see, this is A0 and I take its address, and I'm doing this for, I could have simply written A. I'm doing this for sake of verbosity, and I say A2. You will see that whatever is the address of A0 will be incremented by 4 and then again incremented by 4. Why incremented by 4? Because one integer occupies 4 bytes. Let's say it. Okay, so 1, 2, 3, 4, 5, 1, 1. Okay, so D4, D8 and DC. Look at the last two because rest is similar. D4, D8, DC. So increment by 4. So if your array type is character, it will increase by 1. If it is short, it will increase by 2. So that is the kind of restriction on the memory increment. If it is 8, it will increase by 8 and so on. So that's it for arrays. I've shown you almost every basic principle of arrays, and I don't think there is anything complicated over here. There is something called array of pointers or array of function pointers. I would love to show you array of pointers or array of function pointers, but we have not discussed pointers yet, so it's not fair. Array of characters is a special case. I'll show you, okay, which we have discussed while declaring strings, while discussing scanf. So I say A, comma, B, comma, C. Okay, and then I say \0. I do not need to explicitly initialize all 10. I want to print the string ABC, so I can initialize only 4, terminate with \0, and then I can say put str. So it will be printed. Build it. So again, you see, it is ABC. So I gave the input 1, so 5 elements for first, and then 6, 7, 8, 9, 0 for the other one. So 6, 7, 8, 9, 0. The first 5 are for array A, 5 is N, and 5 are for next. You see, our string is ABC. We don't need anything after \0 in case of array. This is a special case of array. However, in case you want to do like this, big problem, you must never cross the bounds of array, because C does not warn you about bounds of array. C will never give you a warning regarding the fact that you are crossing the bounds of array. Okay, the program didn't crash, right? But we are lucky in this case that it didn't crash. Let's try something. I'm not sure whether it will crash or not, but in all the probabilities it should not run actually. If it is running, then that means you are getting lucky. Okay, still running. Yeah, you see this? From where this came? It tried to access an invalid memory location. this point, C leaves the responsibility up to the programmer that you will be responsible for managing the indices of C. If you program in Java, then Java has an inbuilt exception called array out of bounds exception. But in C or C++, there is no such exception. However, there are tools which will tell you, and the static analysis tools which may warn you, but eventually it's your responsibility. The language by itself gives you nothing regarding bounds checking. So this is the only piece of warning which I would like to give you while using arrays. You need to be a little bit careful. Particularly, it is very common to pass the bounds when you are using strings. Strings are very nasty in C, very dangerous. So that's it for now. See you in the next session regarding pointers. Thanks. Happy coding.